Hello and welcome to the next lecture about merge sort part 2. In previous lecture, we understood how we can divide a given array into subarrays. In this lecture, I try to cover the intuition behind sorting elements. More specifically, I want to show how we can sort an unsorted array from two sorted subarrays. And as you can remember, this is the unsorted array from the previous lecture, and we go one step away before sorting the main array to show how exactly we can sort elements from two sorted subarrays. Let's jump into our codes. This part of code was discussed earlier, and I explained how this part can divide a given array into two left and right subarrays. Merging steps start from here by initializing I, J, and K for traversing left and right subarrays to find the smallest element. Let's get started by the first while loop. This part of code will find the smallest element among two sorted subarrays, and it will put the smallest element into our main array. The length of the left subarray is 2, and I is equal to 0. Accordingly, 0 is less than 2, so the first part of the condition is true. The length of the right subarray is 3, and j is equal to 0, and 0 is less than 3. Therefore, the condition is true. Go to the following line and check if 6 is less than 15. 6 will be selected and we place it at index 0 of the main array. Increment I and then go to the next line and increment k. We increment I to know one element is used from left subarray, and we increment k to know one element is already sorted in the main array. Again, go to the while condition and check if I is less than 2 and j is less than 3. The condition is true. Go to the next line and check if 25 is less than 15. As you can see, if statement is not true, so go to the else statement and do the followings. 15 will be selected and we must place it at index 1 of the main array. Go to the following lines and increment j and k respectively. Then go to the first while condition and check if I and j are less than the length of the left and right subarrays. The condition is true, and go to the if statement and check if 25 is less than 34. As you can see, 25 is less than 34. Then we must place 25 at index 2 of the main array. Go to the following lines and increment I and k respectively. This time, the while condition is not true because I is not less than the length of the left subarray. So go to the second while condition. Please note that when one of the conditions fails, it means that we are done with one of our left or right subarrays, regarding its elements being used for sorting the main array. Additionally, when there is only one subarray to traverse, whether it is right or left subarray, we know that this subarray alone is already sorted. Accordingly, there is no need to have something to compare with. This part of code will find remaining elements in the left subarray. So I is not less than the length of the left subarray, meaning all its elements were involved in sorting process. Accordingly, we should stop executing this while condition and go to the next while condition. This part of code will find remaining elements in the right subarray. The condition is true because j is less than the length of the right subarray, meaning we still have elements to use for sorting process. Go to the next line and place 34 at index 3 of the main array. Then go to the following lines and increment j and k respectively. Again, check the while condition. It is still true, and finally place 90 at index 4 of the main array. Go to the following lines and increment j and k. Go to the while condition, but the condition is not true because j is not less than the length of the right subarray. So stop executing codes, and now the main array is finally sorted. I hope this lecture was useful, and thanks for taking the time to watch this video.